Okay, welcome to Assignment 7. Assignment 7 is pretty much just like 4, except one switch was removed on the right-hand side here. Fiber, instead of being down here, moved to your ISP. So this is your fiber link. Okay, your copper link now goes to the core. That was LA. And links to the spokes became fiber. So essentially, yeah, I just copied the assignment 4, change a few things around, and good to go. Assignment 7 is going to introduce two things. So every network here, every network is going to be part of, hey, subnet for 2000. Okay. Let's see, was that 2000 hosts or 2000 networks? Okay, 2000 subnets. So 2000 subnets. So that becomes, hey, 2000 subnets is down here. So we're actually taking every network there and we're making it a /19, right? Because all of these bits out here, this gives us 2000 subnets and it's a /19. 16, 17, 18, 19. Okay, so every network is going to be a /19. So that means this network is going to be a /19. This network /19. This network /19. This network /19. This network /19. /19 here, /19 here, /19 here. Okay, so this is 1, 2, 3, so we're going to have 8. 1, 2, 3, 4, 5, 6, 7, 8. What we're also going to introduce here is something called a default route. A default route is anything that does not match the routing table. Anything that does not match the routing table, send it out the default path. So that means we are going to route for 20/8, right? And it extends out to every subnet here is a /19. That's kind of burning up a few IP addresses, but it's just to get the idea down. Okay, we'll start dialing up the efficiencies within the next week's assignments. Now, since you are going to be routing for 20 dot anything here, 20 dot whatever, notice here that there is 1.1.1.10 that's sitting out here. You're not going to route for it specifically. You're not going to say, hey, IP route 11.0/30, and you're not going to route for 111.10. What you're going to be routing for is quad 0. Quad 0 is your default route. So it's going to look like IP route quad 0 space quad 0 and the next hop IP. So from this router's perspective, next hop IP for the default is up here. From this router's perspective, for the quad 0 route, it's up here. Likewise for this one, it's up here. From this router's perspective, the default route is up here. okay? For this route here, this router here, its default route is going to be pointing out to this way, okay? And this router here is going to have this route, 20/8. Its next hop IP is 1111.2, 1111.2. So that automatically, based on logic, has to be 2.2 right here. And .1 is going to be right here. Is that making sense so far? Okay, so we can safely assume now that .2 is here, .1 is right there. Okay, and this was 1.1.1.10, right? All right, now, to get these 8 networks then, it's just as easy as doing this. Okay, so those 3 bits, those three bits pass the classful. Okay, so that's network 0, 32, 64, those are your 8 networks that are right there. That's where each of them are going to start. So use the last IP for the host next to the last for the switches. Okay. Next to the last IP for switches. Okay, now you're probably wondering here, how the heck am I gonna figure this out? So 20, well, we can use 20.0 dot, and we're doing this on the 3rd octet, right? And then the 4th octet's over here. So if we take a look at the magic number, which is 32 or 64, 96, 120, right? So if we do one less, the last IP on block 0, that's your last IP. because the next block begins on block 32. Okay, so then what would the last host be for network 32? That would be 63, 254, right? Good, because you're looking at your next block and doing a -1 from there. Okay, so 20.0.95, 254. So for 96, 127, 254. Okay, for 128, since the next block begins at 160, okay, these are our last host. Okay, 160, then that begins. Okay, then 192 and 224. Okay, so 192, yeah, that's right. Then 223, 254, and then for the 224 block, okay, seeing how that's working out there? Use the last IP for your host. Where are the broadcast address? Right? 255. Just make everything 255 here. 31.255 is the broadcast. 63.255 is the broadcast. 95.255 is the broadcast. 127.255 is your broadcast. Okay, I want to show you something else too. If you want to, I mean, yes, you can work this out on paper. I do recommend that. If you want to get a good visual, well, I say good, and that's relative. Okay, so a visual here. Pop open Excel. Now, for Excel here, we got something kind of cool. We could do this. Okay, first of all, if you want to take all this down here and go from 0 to 255, we can do that, right? So yeah, this is one way. And then drag this all the way down to 255, right? So we could do it that way. Or we can record a macro. Okay, so in our macro here, okay, very straightforward. For next loop. For next loop, see, we're going to define I as our integer, and our range we're going to specify 1 through 255. And this is going to begin at the active sheet. It starts at A1. Value is going to be that, and then we're going to increment, and we're going to keep incrementing until we get up to 255. Now, I've tried this, specifying I is 0. Didn't like it. Well, thanks, Microsoft. It's like, oh, well, okay. So if we do this, view macros now, and if we run it, there's our 1 through 255. But remember, in binary, 0 is a value. So let's just account for that. Okay, now we got 0 through 255. Okay, /19. /19 is how many hosts. And we were just looking at this yesterday, remember? Okay, /19, 8190, thank you. 8190, and that equals how many? How many quarters? Right, 32 quarters makes $8. Okay, so 32, we're gonna go in increments of 32. Increments of 32 class Cs. So counting from 0, it's that much. Okay. Now what that means is, yes, that summarizes all of those. Okay, this is 8,190 hosts. So this would be third octet right here. This is third octet. So block zero here goes from 0 to 31. Okay, cool. Now, we need 8 of these. Okay. So we're going to do this. Take our first block that's right here, move it over here. Take our next block that we can use. Drop it in so it doesn't overlap. I just grab all these. drop them down a little bit. Okay, so there are 8 blocks here. Okay, there's your 8 blocks. Let's go one step further here. Let's figure out now where each block is going to go. Okay, so this is going to be LA server. Okay, so that means you should also do this and then do a nice fill color. Okay, so LA server, 8,000 hosts, and it summarizes 32 Class Cs. Okay, next block. Next block would be LA to core. Okay, and that goes up to here. Okay, let's give another color here. How about something like that? LA to core, it's going to be that. LA to SD. What we can do then is keep the contiguous networks that way. We could do it that way. Or we can do allocate the networks this way, then this way. So I don't know. If it were me, I'd want to keep them contiguous down there. And then contiguous down here, then contiguous down here. Okay, SD to core. Give it another color here. Okay, and the next one down here was the SD PCs or SD users. Okay, that's the next block. Next block is down here. Okay, SD users. Okay, what's the next one? NY? Then this one was NY users. Okay, what was the other one? SF? Yep, SF. This last one, SF users. Okay, so here is your demonstration, how to break everything up as if you're doing Lego blocks. Okay, so I showed you the binary method on paper, just like that. And then the second method was building blocks, building Lego blocks. Okay, so two separate visualization strategies for you. Okay, great. So that means we got something to work with now. Okay, we're gonna save this as, okay, so we'll save this first and then do save as. So we'll do this as working. So let's figure out our network. Yep. Which network addresses are going to be okay, so we got that one. Your other network is going to be 32. Right, and we'll just do all the blocks right here and then move them. Okay, what's the next network? 64? What is it, 96? 128? 160? 192? 224. Okay, cool. So got the 32 is the transit there. 64 SD to core, with 96 being down here. 128 is this one. 160 is down here. 192 over here. 224 over here. Okay, for your router to router IPs, I could say use the last IP for the second one, but I'm just, no, don't bother. Just do .1 and .2. It's going to be fine. All right. Okay, so that means .1 is going to be up here. Okay. .1 is going to be all down here. Okay, remember, make the core router .1s. Okay, so that means .2 is up here. .2 is over here. .2 is over here. .2 is over there. .1 over here. .1 over here. .1 over there. Okay, let's get started configuring everything. What do you say? Okay, interface gig00. Description was link to core 20.032.2. All right, gig01 goes out this way to the servers. .20.0.0.1. Okay, and gig00 goes to the ISP. That IP address 10.1.11.2/30. 1.1.11.2/30. Okay, now the default route. See, it's quad 0 there. Quad 0 here, quad 0 there. Next hop IP from this router's perspective is 1111.1. Okay. Let's get the ISP configured. ISP 1941 interface gig 000 link to LA. IP address 1.1.11.1/30, so that's your subnet mask. Okay, gig 0 goes to the DNS web server. IP address 1.1.1.1. Okay, and also it has an IP route. This is the return route. The return route is going to be 20.anything to 1111.2. 1111.2. Okay, so that means this gets configured as that. Services for DNS okay. Notice since we copied this topology from assignment 4, the IPs are going to change, obviously. So the IPs on the host carried forward to this one here. So this is how to adjust on the host side. Okay, here's our core router here. Interface gig 00. Description, link to LA. IP address 20.0.32.1, and we'll no shut. Hopefully we can ping 20.0.32.2. Okay, good. Now, interface gig 000, that's our link to SD. Okay, 64.1. This is our link to NY 20.0.128.1. Zero 20. 20.192.1. Okay. There's our LA. Let's get SD going. Gig 000, link to core, IP address 20.064.2. We'll no shut that. And gig 00. SD users. 96.1. We'll no shut that. Okay, NY. NY 1941. Link to core. .128.2. Okay, and hopefully you can ping 128.1. NY users. Okay, we'll no shut that. Okay, SF. Okay, that's our link to the core. 192.2. Okay, and hopefully you can ping .1. Okay, good. SF users is down the other side there. 224.1. Okay, now that we built that, okay, we're gonna call this all right, so let's start at LA 1941. Okay, and yes, I already put in the default route there because I wanted to show you that really quick, what that looks like. But remember, route to everything. IP route 20.0.0.0/19 Okay, so that was 0. The next one was 32. Next one was 64, right? Next one was 96. Next one was 128. Next one, 160. 192. And then 224 was the next one. $32, $64, $96, $128, $160, $192, $224, and then also the IP route quad 0. Okay, so this one is LA 1941. Okay, so from LA 1941's perspective, to get to anything is going to be out 20032.1. Okay, and that default route, I already dropped it in there, but that default route goes out that side. But to get to all the 20 routes, it goes out this side. Okay, now, which routes are directly connected? 20, and then the 2032. So we are not concerned about that route, not concerned about that route. So therefore, for these routes, we could just paste this in. Okay. How about I save this? I have a feeling I'm going to need to save this too. Okay, LA 2911. Okay. So to get to the 0 network up there, okay, so first of all, we're not concerned about the 32 network because it's directly connected. We're not concerned about the 64 network because it's directly connected. Not concerned about the 128 because it's directly connected. Not concerned about the 192 because it's directly connected. Okay, so we are going to do replace here. Okay, to get to the 2000 network, that goes out 20032.2. Okay, see how that works there? To get to the 96 network, we have to go out 20064.2. 64.2. To get to the 160 network, our transit is 20128. It's 128.2. Likewise, to get to the 224 network, it's going to be 20192.2. Okay, and the IP route, the default route here, it's going to go up this way. Okay, it's 32.2. Okay, so 2911 here. Paste in your routes. Okay, cool. Okay, SD 1941. Okay, so this means everything goes out this way because this is a stub router. So it's going to be next hop IP for everything, including that default route. 20064.1. Okay, 64.1. Okay, what's directly connected? 64 and 96. 64 and 96. '64 and '96. Okay, drop in those routes. On to the next. Okay, this one's NY. Okay, NY, everything. Everything here is going to go out 128.1. replace all. So 128 is directly connected, 160 is directly connected. So that means we can come out over here. Okay, drop in those routes. Okay, recording. We're gonna do the New York routes here. Okay, assignment 7. Okay, that's right. Last one is the SF routes. We just did the, okay, so that means come out over here. And over here, these are the SF routes. Hey, go get your ice cream. Alex. Go get your ice cream. Have fun. Okay. Go. Alrighty. Hey, that one on the microphone. All right, so this one here is the exit IP .1, 192.1. And we're going to 192. Okay, so we're going to replace all those. Okay, SF router here. Okay, paste that in. One thing I forgot was we're not concerned about the 192 or 224 routes. So this is how to get rid of them. See, because as it is right now, that route is exactly in the table as a static route, but we don't need that, okay? Because 192 is directly connected, 224 is directly connected. So that was the 192 and the 224. So to move your cursor right there from the very end to the very beginning is a Control A. Control A does that so you can insert that in, okay? So that was the 192 and the 224. Okay, so there are all of our routes there. So hopefully, at least from now, from this perspective here, we should be able to get to all the router IPs. Like 20.0.160.1, 160.1. Oh, you want your microphone? I'll need to go back and find it. I don't know where it is. Okay, to 160 to 96. Oh, that's a USB cap. Hey, put it right here. Put it right here. Okay. 96. Should be able to get to 96.1. Okay, yep, able to get there. 20.0.0.1. Okay, and we should be able to get to 11.1. Okay, we can get there, 11.1. Okay, now configure all the hosts. Remember all of our last host or last IPs that are right here? So, right, you just translate this, you just take it over, make your labels here. Okay, 20.031.254. Okay, 11110. Make sure you can ping. You should have a route all the way there. Yep, you got a route there. We need to configure the switches. Very important. You don't want to miss out on all of your points. Okay, so configure your host here, which is int VLAN1 20.031.253. Okay, don't forget to no shut, and don't forget your default gateway. Okay, good. Uh, 2960 switch. Since we're here, anyway. Int VLAN1. Okay, this is the 96 network, so 96 network is that. (20.096.1). We should be able to ping all the way since we have all of our routes in. I think, yep, duplicate IP address, because I dropped in the wrong IP address here. (253), we need that one. Okay, now we should be able to do this. So this was 127, right? And this was 96. $253 and no DNS over here. Okay, so NY came from the 160 network. So that should be 191. Okay, and that's 160. So, okay, let's start with this one here. $253. Okay, awesome. Makes it all the way up. Okay, and the switch over here. Oh yeah, no shut. An IP default gateway 20.224.1. Okay, so this also means what you should be doing is tracing all the way to every single host. but I'll let you have that fun. Okay, so that is how to get 100 points on assignment 7. Okay, much of the same, just the introduction of a default route, and then counting up the bits going from this way for 2000 subnets, which gives us the /19. It's just another way of representing that. Okay, configure only static routes. That's exactly what we did. Networks that are starting with 1 dot anything use the default route. Make sure you have a correct next hop IP address. Yep, configure everything here. Place a computer down, right? Enable telnet connections. Yep, got that. Enable console. Privileged password. Oh, looks like we need a couple other records here. Host record for that, and a host record for www.internet.com. Okay. So what's the internet address then? Well, if it doesn't really say, then just do this. One 10 is fine. Okay, that's how to get 100 points. Okay, good luck. Assignment 7. Have fun with it.